Hello everyone, and welcome to this video short where we are going to discuss coping with NP-Hardness. So, as we've seen in some of our examples of this module, there are a number of really important NP-hard problems in computer science, especially many that relate to data science applications. The difficulty here and the complexity here is in fact that the time complexity, how long it takes these algorithms to run. And so again, given that they're NP hard, they're as difficult or as challenging as any problem that exists within NP. So these are algorithms that cannot necessarily be solved in a practical amount of time. So what can we do, right? We don't want our algorithms to run on and on and on. We'd like it if our algorithms would terminate in a reasonable amount of time. And so there's three general approaches that one can take to cope with these NP-hard problems and algorithmic solutions. The first one, of course, is very intuitive, as we've discussed using heuristics and greedy solutions before, and that's simply to find an algorithm that gives us nearly optimal solutions. So here we are going to sacrifice assuring that we get a guaranteed optimal solution. Instead, we will accept a nearly optimal solution if we can get it in a reasonable amount of time, if we can get it quickly. And so employing a greedy strategy to get an algorithmic solution or to use heuristics to get an algorithmic solution is a reasonable approach here. Again, where it's okay to sacrifice an optimal solution so that we can get a solution fast. Another approach, and this is maybe like in a subset of NP-hard problems, is if we have an NP-hard problem that is of smaller size, or if we can restructure the problem so that the size of the problem is smaller, then using something like even a brute force approach, or if we have an appropriate recurrent substructure in the problem solution setup, a dynamic programming problem solution can still be appropriate. Again, this is an okay solution if we have an appropriate substructure for dynamic programming, or if we have a small enough problem where a brute force approach still can be completed in a reasonable amount of time. Within these problems, or within any algorithmic solution as well, sometimes we can employ heuristics to speed up the runtime without too much sacrifice. A third approach is that in some instances, special cases of these more general problems can actually be solved in a practical amount of time. That is, they're not necessarily NP-hard, even though the general problem might be NP-hard. Right? A really good example of this is our problem finding a vertex cover in a graph. Right? As we know that in a general, this problem in a general framework, finding the vertex cover on any arbitrary graph is NP-hard. However, if our graph is a tree, so if we look at a subset of this problem or a specific or constrained instance of this problem, that is, the graph is a tree, we can use dynamic programming to solve this problem because we have an appropriate recurrent substructure, and as a result, we can get a solution executed in an efficient amount of time. Right? The recurrent substructure here comes from the fact that the root of our tree is part of the cover, or its children are part of the cover. And so given, again, that relationship there, our dynamic programming solution and strategy will apply. So again, dealing with and coping with NP-hardness is something that we have to do. And there are three general approaches that are used to attack these NP-hard problems. Number one, look at and try to find a greedy solution or a heuristic that can get us a good solution in a reasonable amount of time. Sacrifice optimality for speed. Right? Approach number two, look to solve smaller instances of the problem if you can. Reformulate the problem, or if you just happen to have a small instance of the problem and you can complete a brute force attack in a reasonable amount of time, try that. And approach number three, look for specific sub-cases or sub-instances of the problem where they can be solved in a reasonable amount of time. All right. Well, thank you for joining me in this video short, and I'll see you in the next episode.